ETL, ELT, data warehouses, data lakes, delta lakes, staging environment, data marts. So many topics. And there are lack of videos and resources explaining about these topics on YouTube. These topics have become very common in today's interviews, especially for the data analyst roles. Of course, these topics are very much important for data engineers, but for data analysts as well. Companies have started asking about ETL, CLT. How does the architecture look like? What is a data warehouse? What is a data lake? And there are no resources on the internet which explains about each and everything in a layman's term. And that's why I'm here. I'm going to help you out and I'm going to explain you about all these topics in this particular video. And what's next? There are so many things that are in pipeline I'm creating in case you are specifically interested in certain topics, let's say time series forecasting or GPTs or large language models. Let me know in the comment section and I'm pretty much sure that I will come up with a concise course on YouTube. Getting back to the topic, this video is all about the general concepts behind ETL, ELT, data warehouses, data marts, data lakes, and so many other topics. See you in the video. Hi, welcome to this module on ETL and data warehouse. In this module, we shall be learning about multiple topics that includes ETL, some of the benefits of ETL tool, architecture of how ETL pipeline looks like. We'll also be talking about concepts like data warehousing, its benefits, structure of data warehousing, architecture of data warehousing, and we shall also be talking about data lakes. Lastly, I'll try to conclude this module by talking about the differences between data warehouse and data lakes as well. Hi, in this video we shall be talking about what is ETL and what exactly each of these terms means. ETL basically stands for extract, transform, and load. Extract means extraction of the data, transformation of the data, and loading into a database or a data warehouse. ETL is a process of data integration that encompasses three steps: extraction, transformation, and loading. In a nutshell, ETL systems take large volumes of raw data from multiple sources, converts it for analysis, and loads the data into your warehouse. What is a warehouse? We will be talking about warehouse in couple of slides. So simply what ETL does is it takes your raw data. Your raw data could be from any source. It takes, does some extraction, and then it basically transforms and then loads into a database. This is the simplest explanation of ETL: extraction, transformation, and loading. Now, what each one of them means in details. What is extraction? What do we actually do in extraction process? What do we actually do in transformation? And how do we load data? In the first step, we'll talk about extraction. In the first step, extracted data sets come from a source. Your source could be anything. It could be from an operational system, could be your sales data, marketing data, it could be any other data, or it could be some flat files. So it could be any source, operation system, or probably flat files. Now, what happens is the staging area acts as a buffer between the data warehouse and the source data. So basically, I'll draw a rough architecture about the ETL pipeline. So we have operating system, we have flat files, and then what happens is then we have a staging environment. What exactly is staging? Staging simply means it's a nearly exact replica of a product environment, of a production environment for software testing. That means before you put your data into a production environment, production basically means your live data where your customers are interacting and all the transactions are happening. You are storing that in a live production data, right? Just a near replica of a production data is called as a staging environment. Staging environments are made to test codes, builds, and updates to ensure quality under a production like environment before application development. So, what we do is we take these flat files or operating system data. So, simply I will mention it data source here. So, this is my data source. This is my staging environment. Now, from staging, what happens is you basically have a warehouse. So I will write down warehouse. I will explain what is a warehouse. So warehouse will have metadata, it will have raw data, it will have all the summary data and so on. And after data warehouse, some of the architectures also have some data marts. Again, what is data mart? I will be explaining. So just imagine all your sales marketing data, it is visible here, and these are called as data marts. I will be talking about data marts in a while. And then finally, once your data is loaded, then your users basically start using this data. So imagine your users are nothing but your BI users who are basically working on some dashboards. So you are getting access to the final data from this layer. So you are extracting the data, you are putting it into a staging environment. From there, you are putting into a data warehouse, you are doing some transformations, and then you are putting into a data mart, and then finally we have the final users. Data mart simply is nothing but a subset of data warehouse focused on a particular line of business, department or subject area. So the staging area is used for data cleansing and organization. So this is the area where you do all the T part, the transformation part. Here you are extracting data, transforming, and then you are loading it to a warehouse and data marts for further use. As simple as that, right? So you have a data source, you are extracting the data from the data source, putting into a staging environment. In the staging environment, you are performing all the transformations, all the data cleansing activities, organization of the data, and then finally you are loading into a data warehouse and data marts. And once the final data is ready in the data mart and the warehouse, end users have started using it. Or let's say, imagine you have a machine learning team who is currently working on a prediction related data, prediction on any use case. They can also directly get access to this data and start working on this machine learning model. Talking about transformation, I already explained everything in a nutshell, but transformation step is simply nothing but the cleansing part, the data cleansing part. The data cleaning and organization stage is the transformation stage. All of that data from multiple source systems will be normalized and convert into a single system format. ETL yields transform data through these methods: cleaning, filtering, joining, sorting, splitting, deduplication, summarizing, and so on. And finally, once your data is transformed, then finally data has been extracted to a staging environment and transformation data is loaded into your data warehouse. Depending upon your business needs, data can be loaded in batches or all at once. The exact nature of the loading will depend upon the data source, ETL tools, and various other factors. So that is all about your extract, transform, and load, which is simply called as ELT. Let's talk about ETL tools. There are multiple ETL tools in the market, and the top 5 are mentioned on the screen. We have Microsoft SQL Server, which is SSIS, Informatica, Azure Data Factory, Apache Airflow, Oracle Data Integrator, and there are various other ETL tools that are being used by multiple organizations. As we are in a world right now where companies are basically using cloud more, probably I'll try to pick Azure Data Factory and I'll try to explain the architecture of Azure Data Factory. In simple terms, Azure Data Factory is nothing but a cloud based ETL. So Azure Data Factory is nothing but a cloud based ETL. It's a cloud based ETL and data integration service that allows us to create data driven pipelines for orchestrating data movement and transforming data at scale. So, what does the Microsoft Azure Data Factory service do? This service basically permits us to combine data from multiple sources. So, when I talk about the architecture, the very first thing that we should start doing is mentioning the data source. Your data sources could be different. It could be from your existing on premises network or could be an external data. So, this is basically your data source. From the data source, you have to extract and then load it into the database or data warehouse. That is the simplest explanation, right? So I'll try to draw the Azure Data Factory here. Azure Data Factory. What's happening inside Azure Data Factory? So first you have the ingestion layer. I will write down as ingestion. So basically data is ingested here, and then from the ingestion layer it goes into the storage layer. Storage. If you want to know what this is all about, this is the orchestration layer. Orchestration. Okay. We have the ingestion layer. So let's say this is the storage blob. Storage blob. And here you have the storage. Let's say we call it as Azure Synapse. Let's say we have Azure Synapse here. Azure Synapse. I'll talk about Azure Synapse. It's again another service by Azure. So data flows from here to here to here. And then from here, the data goes into the next layer, which is called as the analysis layer. That means from this layer, you are able to access the data and you are able to perform the analysis. Again, another tool by Azure for analysis is the analysis services. Analysis services. Okay. And from that layer, we also have the final visualization layer. So I will write down it as Power BI. Power BI is again a BI tool by Microsoft. So this entire thing is your Azure Data Factory. And if you want, you can also put your Azure Active Directory here for authentication. So you can authenticate this and this. And this is a full-fledged Azure architecture. And as we are performing extraction, load, and extraction, transformation, and load, this is also called as an ETL pipeline. Now, what is Azure Synapse here? Azure Synapse is basically an analytics service that brings together data integration, enterprise data warehousing, and big data analytics. It gives you the freedom to query data on your terms. using either serverless or dedicated resources at scale. Azure Synapse brings these worlds together with a unified experience to ingest, explore, prepare, transform, manage, and serve data for immediate BI and machine learning needs. So that's all about the architecture of Azure. So I have used all the Azure tools here: Azure Data Factory, Storage Blob, Azure Synapse, Active Directory, Analysis Services, and Power BI. So various other tools will have various other architectures, but the logic behind the architectures remains the same. It all starts from data source, extraction part, and then we have the transformation part, and then we have the load part. Hi, in this video we shall be talking about data warehouse. This term has already been tossed in one of our previous videos related to ETL. We all remember that it all starts with data sources, extracting, then transforming, and then loading it into a data warehouse. But what exactly is a data warehouse? Sounds like a database, but let's try to understand more on what exactly is a data warehouse. Data warehouse is a large collection of business data that an organization is using to make decisions. The process of constructing and using data warehouse is known as data warehousing. A data warehouse is specially designed for data analytics, which involves reading large amounts of data to understand relationships and trends across the data. The large amount of data comes from different places, such as your internal applications, could be your marketing, sales, finance related data, which we also call it as operational systems, customer facing applications. It could be some of your external systems and could be some other sources of data. But ultimately, you are capturing each and every data and you are kind of storing them in a data warehouse. Your ultimate goal to store in a data warehouse is that tomorrow, if a machine learning team or the predictive analytics team or the BA team wants to have an access to the data, to build something, to build a model, or to build a dashboard, you can easily give them access to the data warehouse so that they can have an access to all the chunk of the data, perform their analysis, and then perform their next steps. The data warehouse stores the processed data, so it's ready for decision makers to access. What do you mean by processed data? Now, initially, when we have the initial data source, which could be your internal systems, this, and this, that data is called as raw data, which is in a raw format. Some of your data could be a part of your database, could be from your JSON objects, could be from some of your MySQL databases, and so on. And when you convert this data or process this data and then perform some transformation logics or data cleaning logics to kind of create a new version of data, which is called as clean data, or in a structured format data, that is basically called as your process data. Some of the important functions which are needed to perform are data extraction, data cleaning, transformation, loading, and refreshing. Let's talk about the benefits of data warehousing. Using a data warehouse is becoming increasingly necessary for today's organizations, especially as many require current information for better decision making. The benefits of data warehousing includes improved data analytics, greater revenue, and the ability to compete more strategically in the marketplace. As more and more companies are growing, More and more companies have started using the concept of data warehousing, the concept of data mart, the concept of data lakes. And that's why, because in order to sustain in the industry, in order to compete with your competitors strategically, you also need data warehouses. By efficiently feeding standardized conceptual data to an organization business intelligence software, BI softwares could be anything like Power BI or Tableau. A data warehouse drives a more effective data strategy. Organizations that use a data warehouse to assist their analytics and BI see a number of substantial benefits that includes better data, faster decisions. Let's talk about the data warehouse structure. A data warehouse architecture is a method of defining the overall architecture of data communication processing and presentation that exists for end clients computing within the enterprise. Each data warehouse is different, but all are characterized by standard vital components. Majorly speaking, there are three types of data warehousing structure. But how does a generalized data warehousing structure looks like? So if I have to draw a generalized data warehousing structure, this is how it looks like. It all starts with data sources. Your data sources could be anything, be it your operational system. I will write it down as operations, be it some flat files. From the data sources, the data goes into a database. Initially, we call it as a staging environment. Staging environment is nothing but a production like environment. After the staging environment, it goes into data warehouse. So this is a data warehouse. After data warehouse, usually it goes into different data marts. DM1, DM2, DM3 and so on. DM3 and so on. What are these data marts? These could be capturing different information like the purchasing information, sales information, employee information or inventory information and so on. And from the data mart, basically you give an access to the users. And finally, the users can work on dashboards. They can basically get an access and work on predictive analytics, on machine learning, on data mining, whatever activities they want to do, they can do. So this is a proper ETL architecture where you are using data warehousing concepts, you are using the data mart concepts and all those things. Moving forward with the official three common architectures. One of them is a basic data warehousing architecture, which could be something without this part and this part. That means you're directly having the data sources. From the data sources, directly data is being transferred to the data warehouse. From the data warehouse, directly you are giving access to the users. The second architecture is going to be with staging area. And the third one will be with staging area and data marts. So what do you mean by staging area and what do you mean by data marts? Let's try to understand in the next video. In the last session, in the last video, we talked about staging environment. Let me just draw again and explain. Let's say we have some data sources, be it from your operational system or file system or any other system, and then you are storing the data in a staging environment. From the staging environment, it goes into the data warehouse. From there, it goes to data marts. And from there, it goes to the users. That is how the flow looks like. Now, as we all know that there are three types of architecture. So an architecture also exists without staging. the basic architecture where you directly feed the data into data warehousing and then directly give access to the users. So why do we need a staging environment? Really, staging environment is not a necessity if we can handle it on the fly. But the question is, can we handle the data on the fly? So let's try to discuss some of the reasons why we cannot avoid a staging area. First of all, let's talk about some of the source systems are only available for extraction during a specific time slot, which is generally less than your overall data loading time. Now imagine this particular file has been given access for a certain period of time, maybe 5 minutes. And then in that location, the file will be deleted or will be sent to a bin or recycle bin. Imagine. Can you directly parse through everything and then push it to the data warehouse? There is a questionable task. It's a good idea to extract and keep things at your end before you lose the connection to the source systems. So before you lose this connection, what if I quickly try to copy it into a staging environment? Because this is a live connection. This connection is a live connection, and live connections could take some time. Maybe there could be some existing records that are being processed. So while you build up this connection and while you transfer these records into the data warehouse, maybe this time could be up. So before that, in parallel to this operation, how about we just copy and paste it to our environment? As simple as there are three people, person A, person B, and person C. Person A has a file. Now A has to pass it to C, but C is currently busy handling some other files. So C cannot interact with A right now. But A has a specific time limit also. In 5 minutes, A has to catch a train or something. So what happens is basically B tries to copies everything to its own database or its own file, and then once C is available, C basically copies and create another replica. So that is the advantage of a staging environment. You want to extract data based on some conditions which require you to join two or more different systems together. Example, you only want to extract those customers who also exists in some other system. You will not be able to perform a SQL query joining two tables from two physical databases. For example, you have a table called as cost and you have another table called as orders or sales. And ultimately, you want to join these two tables and kind of store the information in a particular location or a particular database. So you want to store it in a data warehouse. But as we see that there is a specific time limit. So how about while the data warehouse is busy, how about we kind of store the raw data into the staging environment, and later on when the data warehouse is free, we can again copy the files or copy the records and perform the joins and whatever we want to do and store it into the data warehouse. So that is why we also use a staging environment. Various source systems have different allotted timing for data extraction, as we all discussed. Data warehouse data loading frequency does not really match with the refresh frequency of the source systems. That is also another reason why we definitely need a staging environment. Extracted data from the same set of source systems are going to be used in multiple places. It could be data warehouse loading, ODS loading, third-party applications, etc. ETL process involves complex data transformations that involve or require extra space to temporarily stage the data. So there are multiple reasons why we need a staging environment. Without that is also possible, but it is always recommended to have a staging environment. Let's also talk about some of the disadvantages of having a staging environment. The first disadvantage is staging area increases the latency. That is the time required for a change in the source system to take effect in the data warehouse. That means what's happening here and what's happening here. There is a delay. So there is an increase in the latency. In lot of real-time or near real-time applications, staging area is rather avoided. Data in the staging area also requires extra space, right? So extra space, increase in space is also an issue, space. These are the two disadvantages that I can think of right now, but the advantages are many. To me, in all practical senses, the benefit of having a staging area outweighs its problems. Hence, in general, we basically suggest to designate a specific staging area in the data warehousing projects. Let's also try to understand what are data marts. As we have already explained the architecture in one of our previous videos, which starts with data sourcing, and then we have a staging environment, then we have a data warehouse, and then we have different marts. And from different marts, users are able to access, perform some analytical operations, predictive modeling operations, and so many other things. So what exactly is a data mart and how data mart are different from data warehouse, or basically what is the added advantage of using a data mart? Directly from data warehouse also we can easily access and perform these analytical steps, right? So in short, data marts is a data storage system that contains information specific to an organization's business unit. It contains a small and selected part of the data that the company stores in a larger storage system. Companies usually use a data mart to analyze department specific information more separately or efficiently. Now, the simple difference between data warehouses and data marts are data warehouses are logically something which is at least 100 GB plus. That means the storage capacity of a data warehouse is more than 100 GB, and it also goes into terabytes of data. In other words, talking about data marts are typically less in size, so probably between 0 to 100 GB. You can say under 100 GB. Now try to understand this thing. The entire company information is being stored in the data warehouse. Be it your purchasing details, sales details, customer details, inventory details, everything is stored here, which is terabytes of data. Now, as an end user, you only need to access the sales data. Why do you have to access directly from a data warehouse? Instead, how about we have multiple small storages containing information about sales, purchasing, inventory, customer information, and so on, so that we can directly access it from the smaller data mart. So that will help in reduction of latency and increase the performance of your entire architecture. So that is one of the reasons why we use data marts. In this video, we shall talk about a data lake. We have already tossed quite a few terms related to data warehousing, data marts, staging environment, and so on. Now, we will be discussing about data lake. What do you mean by a data lake? A data lake is a centralized repository that allows you to store all your structured and unstructured data at any scale. You can store your data as is without having to first structure the data and run different types of analytical operations or analytics from dashboards and visualizations to big data processing, real-time analytics, machine learning, and so on to guide better decisions. Why do we need a data lake? Organizations that successfully generate business value from their data will outperform their peers. A survey saw organizations who implemented a data lake. A survey saw organizations who implemented a data lake outperforming similar companies by at least 9% in organic revenue growth. These leaders were able to do new types of analytics like machine learning over new sources like log files, data from click streams, social media, and internet connected devices stored in the data lake. Because data lake has the capability to store data in both structured and unstructured format. You don't have to structure it, you don't have to transform it, you can store it as it is. This helped them to identify and act upon opportunities for business growth faster by attracting and retaining customers, boosting productivity, proactively maintaining devices, and making informed decisions. Now, the question that could come to your mind is, what is the difference between a data lake and a data warehouse? Because somehow both of these terms sound similar. Concepts wise, they are similar in nature. But there is a huge difference in that. In the next video, we shall be talking about the difference between a data lake and a data warehouse. In this video, we shall be talking about the differences between a data lake and a data warehouse. We have multiple points, multiple characteristics based on which we will be differentiating between both of them. First, talking about data. Relational from transactional systems, operational database, and line of business applications. Data lake is a non-relational and relational from IoT devices. IoT is Internet of Things, websites, mobile apps, social media, and corporate applications. In short, in layman's term, in data warehouse, you basically store information from your transactional systems or from your currently operational databases. In data lake, you store both relational and non-relational data, which could be from any source, which could be a structured or unstructured data. Schema designed prior to the DW implementation or data warehouse implementation, schema on right. Data lake is written at the time of analysis. Price or performance, fastest query results using higher cost storage. Query results getting faster using low cost storage. So the storage is basically little bit higher cost in terms of data warehouse as compared with the data lakes. Data quality, highly curated data that serves as the central version of the truth. In data lake, any data that may or may not be curated, that is your raw data. Users, mostly users who are directly accessing from your data warehouse or your data marts, are your business analysts, because business analysts or your BI analysts who basically work on the dashboarding part or on the analysis part, they work on that kind of data that are way structured, because it is easier to analyze a structured data. But there could be many such information in your unstructured data coming from websites, social media, where you could correlate, and you can correlate those kind of data with your existing operational database data, and using your correlations you can basically do better predictive modeling. So usually data scientists, data developers, they use these kind of data. These are most of the users who prefer data lakes. Analytics, batch reporting, BI and visualizations. In data lake, as we already discussed, machine learning, predictive analytics, data discovery and profiling. So in short, if you ask me which one would I prefer, if your organization is mostly working on the predictive analytics part or on the machine learning part, on the AI part, where they are trying to leverage your structured and unstructured data, you can definitely go ahead with data lake kind of approach. because the large volumes of data in a data lake are not structured before being stored. Skilled data scientists or end-to-end self-service BI tools can gain access to a broader range of data for faster than in a data warehouse. So that's why we prefer data lakes over data warehouse. Let's try to talk about some of the elements of data lakes. And then we'll be discussing what are the benefits of data lake. Some of the elements of data lake are data movement, securely storing or secure storage, analytics, and machine learning, or you can also call it as AI. Data lakes allow you to import any amount of data that can come in real time. Data lakes allow you to store relational data like operational databases and data from different line of business applications, non-relational data like mobile apps, IoT devices, and social media. So you will be able to store it and with a secure storage. Data lakes allow various roles in your organizations like data scientists, data developers, and business analysts to access data with their choice of analytical tool and frameworks. And lastly, using the data scientists or machine learning or AI related teams, they can leverage from the data and start building the predictive modeling. So data lakes will allow organizations to generate different types of insights, including reporting on historical data and doing machine learning where models are built to forecast likely outcomes and suggest a range of prescribed actions to achieve the optimal result. So some of the benefits of data lake are improved customer interactions, improved R&D innovation choices, and increase the operational efficiencies. So that's all about this particular video on data lake. I hope you understood the end-to-end concepts related to data lakes. That's all about this particular video, guys. I hope you enjoyed it. In case you did, please don't forget to like, share, and subscribe the channel and leave a comment in the comment section because that is most important. See you in the next video. Bye bye.